cos x versus cos h(x). You would have surely seen cos x function a lot of times. Right from your school days, you would have seen cos x and you will be very familiar with this. What is cos h(x) and what is the difference between cos x and cos h(x)? This is what we are going to discuss in this lecture. First thing I want to clarify is cos x you are already aware of. It is a trigonometric function. This you will be very aware of. What is cos h(x)? This does not come from trigonometry. This comes from hyperbolic geometry. So this is a hyperbolic function. It is cos h(x). What I'll do is, first we'll draw the graph and have an idea, and then we'll discuss about what is cos h(x), what is cos h(x), what is cos x, and what are the differences. First thing, before we go to the graph, one more thing. Let us clarify this, that the range of this function is from -1 to 1. This you already know about cos x. What about cos h(x)? For this, the range is from 1 to infinity. So this is the main difference between cos x and cos h(x). Cos x takes values and gives you -1 to 1, but cos h gives you 1 to infinity. Let us first see the graph. The reason I want to show you the graph is it gives you a clear imaginary idea of what this is. It stamps it in your mind. After that, explaining the function will be much easier. Okay. So we'll first draw a graph. Let us say it is something like this. In this, first I'll draw cos x. So I'm going to draw cos x first. Let us say it goes something like this. It is a periodic function. It will go up and down. So because I drew like this central point, this point should be 0 because cos x takes largest value here. I'll take this as 0. Because the graph is growing like this point should be -1, and the top point where it is coming, this should be 1 because cos x can take maximum 1 and minimum -1. So somewhere here you have 0. Okay. So according to whatever I have drawn, I have given the values in the graph. Next thing is, this is cos x. So I'll mark it as cos x. This is the graph of cos x, the red one. Now I'll draw cos h(x) and then we'll compare. Okay. If I draw cos h, it will look something like this. It will go up from here and again up to the other side as well. This is how cos h will look like. This is cos h. Cos h(x). What is the speciality of this function? Your actual cos function, the trigonometric one, it was taking maximum value up to 1, but cos h is starting from 1 and going up. So it can take any value, but the speciality is all the values taken by cos h(x) are positive. Even if you give negative value or if you give positive value, cos h(x) will always give you positive result. But in case of cos x, it can be negative or positive because it can take values from -1 to 1. But in case of cos h, it will always give you positive values. Even if you give it negative value, the cos h(x) output will be positive. So the speciality of this, it is increasing. It is somewhat like a hyperbola, but it is growing faster than a hyperbola. So that is this cos h(x). So next thing, I'll write the mathematical formulation. For cos x, how you generally write it is, cos x can be written as e power ix plus e power minus ix whole divided by 2. This is how you generally write cos x. But if it is cos h(x), you can write it as e power x plus e power minus x whole divided by 2. So the imaginary part is gone off when you went to cos h. One more thing, in the last lecture, we learned about Taylor series. We learned that using Taylor series, you can find an infinite polynomial approximation, an expansion that will approximate this particular function at any particular point x is equal to a. So let us apply that here. Let us try to find cos x and cos h(x) using Taylor series expansion. So using Taylor series, this is how the value will look like. If I do it for cos x, it will look like, So I'm just writing the values so that you understand the difference between cos and cos h. Okay. So this will be 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial. So you understood the pattern, right? So then I'm writing just dot dot dot. It is an infinite series. Same thing if you write for cos h, the pattern will change. The pattern will be 1 plus x square by 2 factorial. See, this pattern we already used in the last to last lecture where we learned about log cos h loss. So I'm just writing it down here. X square by 2 factorial plus x power 4 by 4 factorial plus x power 6 by 6 factorial and so on. So this is the expansion for cos hx. So there is a slight difference that the negatives are all positives in case of cos h. So because of this, here because you have positive and negative, the positive will cancel out the negative, negative will cancel out the positive. So always the value will be between -1 to 1. But in case of cos h, it is all plus, it is increasing in value and it is increasing abruptly. That is why the value is from 1 to infinity, right? So cos alternates the signs, but cos h is always positive. This is how you can simply understand. Next thing is, let us just see this graphical behavior and understand what is this graphical behavior. First thing, in case of cos x, you know it is between -1 and 1 and it is periodic around 2 pi. So every 2 pi interval you will see cos x again and again repeats. That is why at every interval of 2 pi, cos x function will repeat itself. That is why it is periodic. This you would already be knowing. I just explained so that I can next explain about cos h. So cos h is always greater than or equal to 1. It is not a periodic function. It does not repeat. It grows exponentially as the value of mod x increases. The reason I said mod x is that even if it is negative or positive, when the value of x grows, cos hx grows. Okay. And it is symmetric around the y-axis. Here I put 0 here. That is why it is not looking to be around the y-axis. Actually, it is symmetric around the y-axis because ideally the axis would be drawn here around 0. Here because I already drew cos x here, so I put the graph accordingly. Ideally, the y-axis line should come here. So cos hx would be symmetric around the y-axis. Next question is, what is the geometric interpretation of cosine? So cosine's geometric interpretation, most probably you would already be knowing, but I'm still telling you that in case of cosine function, the geometric interpretation of cosine, cos, is that it relates to a point on the unit circle x square plus y square is equal to 1. Probably you would be already aware of this. But what is the parallel geometric explanation for cos h? That is what I want to tell you. So in case of cos h, instead of the unit circle, here it becomes unit hyperbola. So it relates to a point on a unit hyperbola. Then the equation of hyperbola will be x square minus y square is equal to 1. So this is the difference. Cos x means a point on the unit circle and cos hx means point on unit hyperbola, right? So this is the geometric interpretation. Next thing we need to discuss is, yes, we need to discuss about derivatives. What is the derivative of cos x? That is, if you do d by dx of cos x, what do you get? You get minus sin x. So this is what you already learned about derivative of cos x. What about the derivative of cos hx? If it is instead of cos x, if it is cos hx, then the negative won't be there. The derivative is sin h of x. So this is the derivative of cos hx. So about cos, you know it is bounded and oscillatory. But about cos h, you know it is unbounded and exponential. So these are connected through Euler's formula. Okay, let's leave it there because it may not be significant for you. For now, just understand that cos x and cos h. The reason I kept this lecture here is we already discussed about cos h in a lecture before this. So I want you to be clear on it is different from cos. It is not the cos function. Cos h is different and how it is different from cos x. So this much basic should be good enough for you. You are not going to go deep into cos h function and all. So in the next lecture, we'll again continue with our regression loss functions. We'll go to the next regression loss function we have. And then let's continue with loss functions. That is our main part. In machine learning, we are understanding loss functions and how to use them. Okay.